Hi, this presentation is about Project 210, Coastal Hazards in a Variable and Changing Climate, and I'm going to talk about our achievements over the past 3 years. I'm Kathleen McInnes and my Deputy Chief Investigator is Mark Hema. We're from CSIRO and we collaborate with organisations such as the Bureau of Meteorology, ANU, the NCCC at Melbourne University. The hub challenges that we're addressing are coasts, extremes, and to some extent water availability. The research that we undertake is of critical importance to Australia, which is a coastal nation, exposed to hazards such as rising sea levels, storm surges, and extreme waves. We research these hazards and also develop tools and products relevant to a range of stakeholders. The following short video just captures some of the issues that motivate our work.
Riders on the storm, into this house we're born, into this world we're thrown.
As illustrated in the video, our work spans processes from the global to the local scale, and we monitor past changes and develop information about the future coastal hazards. I'm now going to talk through some of the science that we do. Members of the 210 team work on the development of data streams from satellite missions. Trends in sea level rise are routinely processed from the satellite altimeter missions to provide evidence of increasing sea levels and sea level acceleration. The team at ANU work with the GRACE gravity measurements to evaluate how much of that sea level rise is coming from the melting of ice sheets and glaciers. As the red in the top figure shows, West Antarctica is showing increased signs of melting and contributing to the sea level rise that we're experiencing. Ocean waves are a major focus of our work, and we've used a 35-year wave hindcast to investigate how modes of climate variability such as the SAM, the Southern Annular Mode, MJO, El Niño Southern Oscillation blocking, and the Indian Ocean Dipole affect wave characteristics such as wave height, period, and direction. The figure shows that during SAM negative phase, wave heights tend to be lower across the Southern Ocean, that's the areas in blue, and stronger in the mid-latitudes. Since climate change produces changes more consistent with the SAM positive phase, this means that the pattern flips and in the future we'll see increasing wave heights from the Southern Ocean affecting our southern shorelines. Mark Hema developed and coordinates the CowClip project, which coordinates wave researchers internationally to address key science challenges in wave climate projections. Some key highlights are a synthesis of the results of 91 global and local wave climate projection studies to determine the degree of certainty of wave projections across the globe. Their finding is that 50% of the world's coast is at risk of future changes in wave climate. We've developed data sets and methods for understanding the causes of extreme impacts. For example, the East Coast low that caused such devastating impacts for Sydney beaches in 2016 was primarily due to winter king tides in combination with severe waves from an unusual direction from the northeast. We've tailored our data sets, such as our sea level projections, to a range of end users such as NCAR and for use in the Coast Adapt portal. In terms of our extreme sea level research, we have increased the length of digital tide gauge records at Williamstown through data digitisation, thereby increasing to 3 the number of tide records in Australia with over 100 years of data, the other 2 being at Fremantle in Perth and Sydney Sport Denison. This is an activity we do with the help of Year 10 work experience students. So it's a way of engaging with STEM students and teaching them about the science we do while getting them to help. And we've also developed tools to enhance our delivery of extreme sea level data to a range of stakeholders. One of these tools is the Canute web tool, which primarily delivers extreme sea level information around Australia's coast based on our models and data for coastal engineers and managers. We've undertaken modelling work to address sea level projections, future wave climate and future storm surge changes. And this figure brings the results of those 3 studies together to highlight what parts of the coast these 3 different hazards are coming together. On the south coast, it's primarily waves that will undergo increase. Along the east coast, sea level rise will be higher than the global average. On the northeast coast of Tasmania, extreme waves together with higher than average sea level rise will come together, whereas on the northwest shelf, both storm surges and extreme waves are tending to be lower in the future, and sea level rise is slightly lower than the global average. In Project 210, we've also had a focus on data delivery to next and end users. We've revamped our web presence to include dedicated pages on sea level rise, waves and coastal extremes, and provide a platform for delivering tools, information and data sets. Our web page has received over 18,000 views since it went live about a year ago. And we've also delivered tailored sea level projections, as mentioned before, to NCARP and other stakeholders such as the Tasmanian Government. We've also published our research in over 21 peer-reviewed journal publications, and we have strong visibility internationally through our participation in global networks and affiliations such as the Intergovernmental Panel on Climate Change and the WCRP. I've mentioned our sea level waves and storm surge research. We've also used our data sets in collaboration with university researchers to better understand the dependence between storm surges and extreme rainfall around the Australian coast. The researchers at Adelaide University applied their statistical analysis to observations in the top panel to show that storm surges and extreme rainfall tend to coincide in the coastal regions where the dots are red and tend to be independent where they are blue. Our model storm surge data was able to give a more complete picture of how these extremes behave around the coast. We also looked at the types of weather events responsible, and in the north, tropical depressions and cyclones tend to be a common cause of the coincident extreme rainfall storm surge events, whereas on the south coast, cold fronts tend to be the cause of storm surges. And while they produce rain, it's not generally really extreme rain, whereas the heavy rainfall tends to be caused by convective systems at different times of the year, and these don't cause storm surges. Other benefits of the work we do include creating lengthened data sets, developing new tools, collaboration with other Australian researchers, strong international collaboration and engagement with the community at large. And our recognised expertise tends to lead to greater visibility of the work that we do. So where to next? We intend to continue our research into the factors contributing to coastal extreme hazards, with a focus on next generation coastal climate projections to ensure that the information is fit for purpose and building on the work of the CSC, the Grand Challenge for Sea Level in improving coastal climate services internationally. We'll also work with our partners in the ESCC to better understand coastal vulnerability by linking their historical understanding of past coastal change with our projections of future change to increase confidence in our projected changes. We'll also work to develop new types of coastal projections such as marine heat waves, and this work will continue in Project 5.8. So that's all from me. Thank you very much for listening.